Good day, this is Kim Valpola, and in this video we're going to talk about the difference of AC and DC system and their applications in real life. Electricity is the presence or flow of charged particles. The flow of electrons around the circuit is called an electric current. You may notice that two circuits are represented. This is because current flows in two ways, as an alternating current or AC or direct current or DC. The main difference between AC and DC lies in the direction in which the electrons flow. If a current flows in a single direction in a steady voltage, it is called direct current or DC. The current flows from high voltage to low voltage unidirectionally. We can see in the illustration that the electron flow travel from negative polarity and is attracted to the positive. We can see two horizontal lines which represents steady DC. In alternating current, we can see that the current flow changes its direction periodically, forward and then backward, and forward and backward. And one electric cycle or period is represented using a sine wave. Thus, it is used for AC. AC as a waveform of sine wave. As shown in the graph, both AC voltage and current rises and falls periodically. The current reverses direction 50 to 60 times in a second, depending on the frequency. Here in the Philippines, is 60 Hz. The following are general differences of AC and DC. For power factor of an AC circuit, it ranges between 0 and 1, while for DC, it is always 1. The passive parameter for an AC is impedance, having a combination of reactance and resistance, while for DC, there is only a resistance. For the type of load, it can connect with resistive, inductive, and capacitive type of load. While for DC, we can only connect with a resistive type of load. The conventional method to transmit power is the HVAC transmission system. The laws are more than the HVDC transmission system. The most emerging technology for transmission system, which is for the direct current. We can convert DC to AC with the help of inverter. While using a rectifier, we can also convert AC to DC. We can get an AC from the AC generator, while we can get DC from a DC generator as well, and from a battery or from cells, like solar power cells. Undisputedly, AC is dangerous. While with the same rating, DC is more dangerous. Advantages of AC transmission system. AC circuit breakers are cheaper than DC breakers. The repairing and maintenance of an AC substation is easier and inexpensive than DC substation. Due to skin effect, the losses of AC system are more. Due to the capacitance in transmission lines, a continuous power loss occurs when there is no load on the power lines or if the line is open at all. There are some additional line losses due to the inductance. The coronal losses occur in an AC transmission system. AC transmission lines interfere with other communication lines. There are stability and synchronizing problems in AC system. AC transmission system is less efficient than the DC transmission system. There are difficulties in controlling the reactive power. Now, let's go on to the DC. Disadvantages. There are two conductors used in DC transmission, while three conductors are required in AC transmission. There are no inductance and surges or high voltage waves for measured time in DC transmission. Due to absence of inductance, there are very low voltage drop in DC transmission lines as compared to AC. There is no concept of skin effect in DC transmission lines. In high voltage DC or HVDC transmission lines, there are no dielectric losses. In DC transmission system, there are no difficulties in synchronizing and related stability problems. DC system is more efficient than AC. Therefore, the rate of price of towers, poles, insulators, and conductors are low, so the system is economical. Now let's go to the disadvantages of transmission of DC. Due to commutation problems, electric power can't be produced at high DC voltage. There is a limitation of DC switches and circuit breakers, and they are costly too. DC transmission system is more complex and costly as compared to the AC transmission system. Let's go on to the AC application. Alternating current tends to be used for power distribution. This is because of its advantage that it can easily be converted to other voltage levels using a simple transformers, which do not work with direct current. If power is distributed at a high voltage, then less energy is lost during transmission. It is for this reason that high voltages are used for power transmission and then reduced to a relatively safe level for use with domestic and commercial properties. Because generating and transporting AC across long distances is relatively easy, thus home and office outlets are almost always used in AC. Now for the DC application. In a solar power plant, energy generated in the form of DC current, the AC power cannot be stored like DC. So to store electrical energy, always DC is used. High voltage power transmission is possible with HVDC transmission line. There are many advantages of HVDC transmission system over conventional HVAC transmission system. An HVDC system is more efficient than an HVAC system, as it does not experience power losses due to the coronal effect or skin effect. In domestic and commercial building, DC is used for emergency lighting, security camera, and TV. Batteries. Both non-rechargeable and rechargeable can only supply direct current. The rechargeable batteries also need recharging using direct current. electronic equipment or gadgets, such as computers, radios, mobile phones, and in fact, all electronic equipment uses direct current to power the electronic system. Bipolar transistors, FETs, and the integrated circuits that use these components all need directed current to power them with all damage and will damage if a reverse polarity is applied. All electronics or most power electronics, project circuits and parts run on DC. Everything that runs off a battery or solar cells plugs into the wall with an AC adapter or uses a USB cable for power relies on DC. But you might find that you have AC in parts of your circuit, for example in audio circuits, radio circuits, or in other power supplies. The AC part is usually either a signal that represents something like a sound, or also an oscillating voltage to send a signal out to the field like a radio transmitter. So to compare AC versus DC, in many areas there can be a decision to be made of AC versus DC, and which form of supply is best for a given application. Alternating current or AC and direct current or DC both have their advantages and disadvantages, but this means that there is a choice to select the best option for any given use or application. Alternating current is generally used for power distribution, which is why the main sockets in our homes and at work provide an alternating current to power whatever is needed. But DC is more widely used for electronic boards themselves and for many other applications. The following are my references during my research, so I would like to send my thanks. Also, if you want to read more, you can visit these sites. Thank you for listening and God bless.